Hello. Are we microphoning? Yes, we are. I am going to spend a lot of this talk dissing shiny things. So if you like your hardware, buckle up. I'm going to get rude. But I want to start by giving you a bit of my background, kind of how I got to this place, because it's been a long and slightly weird journey with some really interesting learnings along the way. So, oh, that was interesting. That was not what was supposed to happen when I clicked the next button. We a slight pause. That's because I'm on Nikki's slides. Hi, I'm awake. Let's try that again. Okay, so this is me. As Amanda mentioned, I started ADSEI, which is also known as ADSE, which is the Australian Data Science Education Institute. And I started that in February of this year for a lot of reasons, which I'm going to start giving you a kind of background on now. So the question is, why me and why the Australian Data Science Education Institute? I started a PhD a number of years ago that I won't list because it scares me. Oh, by the way, my slides are at that link. If you want to grab the slides, feel free. And I will put that up again later. So yeah, I started the Australian Data Science Education Institute to solve a problem, and the problem started, or it became clear to me when I started my PhD. So my PhD was in computer science education, and I started to design a programming language. And with the arrogance of youth, I called it Grail, a genuinely readable and intuitive language. Go home, go hard or go home, right? I should have gone home. It was atrocious. It was really terrible. My favorite review of Grail was that it was sexless, which fascinated me because sex was never something that I had looked for in a programming language before, and it kind of confirmed to me that maybe I'm actually not nerdy enough for this game because I'm still not looking for sex in a programming language. However, it was dull, it was tedious, it was terrible. But in the design and testing phase, I learned a lot about psychology, I learned a lot about learning, and I learned a lot about what is important in teaching people to program. And the fundamentally most important thing is motivation. And this is what eventually led me to teaching in Python, because you can do real stuff, and you can do real stuff straight away. But I will come to that. So when I left academia and started at John Monash Science School, it's a science school, right? Packed full of nerds who you would think would already understand the need for computation. Unfortunately, that wasn't really the case. And part of the reason that wasn't the case is because what we were doing in that first year, which was 2010, and we started out with, sorry, that didn't come out very well, a thing called Starlogo, which was kind of, it was block-based, very much like Scratch, but it was designed for simulation. So science kids, teaching them simulation, the motivation is built in, surely, except that it's not real, and you hit the boundaries of it really fast. You start to do anything complicated, and it gets complicated. You can't do it. They introduce too many sprites, and the system falls over. It was traumatic. And that was for the kids who already knew how to program, were pushing the boundaries. The kids who didn't know how to program were also hitting the boundaries of this, partly because block-based languages very rarely have any form of debugging built in. So we had situations where scripts would simply stop running with no error messages, and it would take me, with a PhD in computer science, 10 to 15 minutes to debug. The kids had no chance. So the other teachers with no programming experience had even less. So there were a lot of issues with teaching the block-based stuff, and the kids, for the most part, hated it, whether they could already program or not. They hated this stuff. The other thing that we did in that year was we did Lego robots, but with Mindstorms. Now, I love my Lego, and Lego instruction books like this are a masterpiece of usability and communications. Lego Mindstorms is not. It is, this was the first time I'd seen it, was when JMSS started teaching it, and oh my God, it's bad. It is phenomenally difficult to work out how things work, what the individual blocks do, how to connect things. The kids who were already excited about robots went and ran with it and started doing fun stuff, except that they weren't allowed to do fun stuff because they were told they had to work through this set of, anyway, won't go there. It was tedious because Sometimes the hardware failed, so the sensors would stop working, and you had to debug, was it the code, was it the sensors? And of course, as soon as a student has a situation where the hardware has failed them, every time their code stops working, must be the hardware. It's not my code. It's got to be the hardware. And they bail. They're just like, well, I can't do this because I don't know whether the hardware's not working or the code's not working. They just give up. So Mindstorms, again, not a huge success. The kids who already loved it kept having fun. The kids who didn't would rather poke themselves in the eye with a sharp stick than do this stuff again. This, you know, drones are fun. Even I don't like hardware, but I get excited about drones. And this is a drone that my 11-year-old bought at Comic-Con. They're a massive Star Wars fan. The excitement about this drone was intense. Took it home, charged it, turned it on. Didn't work. PhD in computer science. My husband's an electrical engineer. We spent the whole weekend trying to debug the damn thing. Could not make it work. Emailed the suppliers. A couple of days later, got a thing back. Eventually, we got a new drone, which worked. It was a hardware problem. My husband's now happily taking apart the one that didn't work to find out where the problem is, but he still hasn't found it, right? With a multimeter and a soldering iron, he still hasn't found the issue. So what that taught my 11-year-old, with their intense love of Star Wars and their passionate love of tech, was that they couldn't do this stuff. When it failed, there was nothing they could do about it. They tried everything, and they were phenomenally persistent, which is, you know, it impressed the hell out of me, but in the end, they didn't get anywhere. So it taught them that hardware is not something they can do. This was not the message I wanted my 11-year-old to get. It really wasn't. So we moved away from Starlogo and its hideous brethren to a Scratch-based language called Scribble. And we taught the kids to draw pretty pictures. Pretty pictures with maths, right? We have sine waves. So you've got your maths and you're building it in with your tech. And the number one bit of feedback we were getting was, why are you making me do this? I don't like it. It's not relevant to me. Why are you torturing me? Science nerds thinking that programming is not relevant to them. Bit of a problem. Of course, this is Turing complete. Hideous though it is, and it has scarred me for life, it is Turing complete. It is a real programming language. You can do anything in that you can do in any other language. It was not enough to make the kids motivated. They looked at it and went, this is a children's toy. We are year 10s. Why are you forcing us to do this? So I pushed hard for years to persuade my head of department that we needed to move to Python. And eventually we did move to Python. Oh, sorry, forgot the screaming. So we moved to Python, and it was great because it's Python, right? It's nice and easy to learn. It's nice and readable. It is, and you can do real stuff in it. I thought, here we have motivation built in. The kids are going to know that the skills they're learning in Python are things that they can use straight away. And it turns out that you can do pretty sine wave pictures in Python as well. And still we were getting, why are you making me do this? This isn't relevant to me. Why are you forcing me to learn programming? It's not something I need. Science students. Programming is not something I need. I'm sorry, guys, I've got some really bad news for you. Still screaming. Always with the screaming. And at the same time, as we were teaching this year 10 course to an entire, very reluctant cohort, I was teaching a year 11 course, which was an elective, and it was a computer science course, specifically computational science and data science. And the capstone project in that course was to do real projects with real scientists working on their data and providing them, ideally, with software that they could use. This is Matt and Chris with Dr. Michael Gantier, and they did cancer research in year 11. This was my first year 11 class. To the best of my knowledge, that software is still being used today. It was phenomenally useful. They went on, they were still working on it the next year in year 12, much to the disgust of their other teachers. Because it was interesting, it was relevant, and it was useful. They could see the point. Now, elective subject, right? So it's not the same as the year 10 context. Another example was Dolphin Oat, which was a collaborative project with an organization called Polpero, who do dolphin tours in Port Phillip Bay out of Sorrento. And they had something like 8 years of data on the dolphins in Port Phillip Bay, and they let us play with it. Unfortunately, that was the data. Not what we think of as data. And the group that did this project, they decided very quickly that this handwritten data stuff had knobs on it. And so they made an app to get to allow Polpero to record the data directly in a digital form. They printed out the forms that needed to go to the Department of Sustainability and the Environment because it still had to be printed out in those days. And they did this amazing project with a server-side program and an app, and it was usable, and it was robust, and it was awesome. And again, useful things, so they were still working on it in year 12. Then we have these guys who did a project last year in Genomics. They worked in 2 teams. One was predicting the structure of microRNA, and the other was predicting whether a given sequence was, in fact, coding for microRNA or not. I'm not going to go into the biology of that. If you want to know, ask me later. But again, they broke new ground. They did something that hadn't been done before. They presented their work at Lawn Genome Conference in February of this year. Again, they're still working on it. Oh, and this guy at the front, second from the right, his name is Victor. He wasn't doing my subject, but he came to me and he said, please, Dr. McIver, please, can I do this project? And he spent 10 minutes trying to persuade me that he had skills that were useful to the project, which I knew because I had taught him the year before. What do you do when a kid comes to you and begs you to do your assignment when they're not doing your subject? Sure. And he was a great contributor to that project. But that's the attraction of these projects, right? They're doing real stuff, they want to do them, and they're not just in it for the marks. So all this stuff is happening in year 11, and I know that it's working. And in year 10, I'm still fighting to get real things happening. And meanwhile, data is ruling the world. It is changing the world, and it is becoming a serious issue. And in the year 11 course, we had privacy and ethics units where we would talk about the way our information is used. We were talking about Cambridge Analytica 2 years before it went, all over the media. And the kids didn't really understand the implications of data on their lives. And that's not a big surprise to me because we don't really understand it. Even in the tech community, we don't fully understand the implications. And that's because the implications haven't really become clear yet. We don't know what the possibilities are. But it was becoming obvious to me that we needed that literacy, that data literacy. We needed those data skills. So, because no one's understanding how data is ruling the world, data companies like Cambridge Analytica, and they're just the tip of the iceberg, they're just the ones we know about, they are running away with our data and doing all kinds of things to us that we don't understand. How do we fix that? We need a data literate generation. So what happens if we teach the year 10s data science? Instead of drawing pretty pictures, if we use Python to grab a data set, analyze it. Okay, we're not going to do the visualizations in Python for most kids because matplotlib is a nightmare. But we can analyze the data, right? We can pull the data out of the file, we can find particular bits, we can look for particular relationships, and then a lot of them did their visualizations by hand, which was pretty compelling. So the first one we did was on the AEC, the Electoral Commission data set, where we downloaded all of the votes for the Senate in the federal election in Victoria. It was a 3.5 million line file, which was perfect for my purposes because you couldn't even open it in Excel. On most systems, it just hung. On some, it opened after about 10 minutes and crashed. But even if it did open, then scrolling was impossible. It's just more data than Excel can manage. So this is great because motivation is right there. Sorry, guys, you're going to have to do Python. There's just no other way to manage this data set. And they could ask questions like, where are the One Nation voters? So one of the visualizations was whether how many are rural, urban, and inner city. Which party is more likely to follow the how to vote card was an interesting one. It will come as no surprise to you that the Greens were the most rebellious. But they could ask any question they wanted, right? Because they could use Python to look at their correlations. Where are the below-the-line voters? Who votes below the line, and where do they come from? Because the data set had the electorate and the polling booth, as well as the vote information. How many people cast invalid votes? All of this kind of stuff appears in the the data storytelling on things like the ABC after the election, but the kids were asking questions that didn't appear in those kinds of things. So they were finding out new things. And what I stopped getting was, why are you making me do this? And what I started getting was, oh my God, I can't just do that. I can do these other things. Last year we did a climate change project and we worked with modeling data. So we had really a very simple data set, only it was in JSON files, which added a little extra pain and screaming. And we got to ask questions like, how long will green sea turtles survive? Because green sea turtles, their gender is determined by the temperature of the sand. So if the temperature increases, you get less boys. And actually, that graph was really depressing. I'll show you that later. Which parts of Melbourne will be underwater in 100 years' time? And the cool thing about the data sets we had was that they were a whole lot of different scenarios. So the climate change data, the models are based on various assumptions. One is that we fix the whole CO2 emissions thing now, and it's not going to happen, but we had that data set. We had what happens if CO2 emissions continue increasing at the rate we have, basically the worst case scenario, and we do nothing about it. And the kids could choose which one they wanted to use, or they could go for an average, or they asked their own questions with their own interpretation of the data set. This is the turtle graph. So the yellow is the temperature of the sand. The red represents boy turtles. Each turtle represents 10% of the population. And you can see that by 2030, we have a very tiny percentage of boys left. And by 2060, I mean, realistically, we're not going to get there. There's not enough boys to sustain the population. So this was Francine's effort to make the data compelling. So the whole point of teaching data science was not just learn some code and analyze the data. It was then how do you tell the story? Because if you can analyze all the data you want, you can find the most incredible results. If you can't communicate it, you might as well have not done it. So the whole point was, how do you communicate that? So Francine wrote code to extract the data and analyze it, and then she did her visualization by hand. This was one of the outcomes of the election project. And this kid, Jack, decided that he actually wanted to use past polling and the results from this election to see if he could predict future elections. So this is the program that he wrote, and the idea is you tell it what the party is currently polling at, so you drag the sliders, and then it produces a diagram of who gets the vote. So this was the South Australian election that happened, I've lost track of time, earlier this year or last year. The orange is SA Best, or the Xenophon Party. Blue was Liberal, black was Independent, and red was Labor. Now, that was based on the default polling numbers, which of course was never the way they polled. And in fact, when you put in the accurate polling numbers, the output of Jack's program was startlingly accurate. So when we switched from Cellular, which was a Scratch-based simulation package, to doing data science in Python, this was roughly the shift in the feedback that we got. So you can see that with Cellular and Scratch, the perceived relevance is heavily weighted towards why the fuck am I doing this? And with data science, the perceived relevance is much better down the other end. Now, it's not great still. There are still people, not many, but still people who think it's not relevant at all. But let me tell you about that instantiation of the course. This was the first time we'd run data science with the year 10s. We had one teacher who knew how to program, teaching that subject over 6 classes, I think we had. So there was one of us who knew how to program. I was building the course as we were teaching it. We didn't have the staff to run it. We didn't have... It took us ages just to work out what the data set actually meant, and I'll show you that in a minute. But it was really flawed. It was, as the first run often is, it wasn't great. Nonetheless, the shift in relevance was massive. So I want to digress for a little bit and talk about why I think it's so important that we understand data. Hands up if you think that your decision making is basically rational and logical and based on facts. Couple of hands up, not many hands up, that's good. I've got some bad news for those of you whose hands were up. This is one of my favorite studies. Who's heard of the Israeli parole board study? A couple. So what they wanted to know was, what are the factors that influence whether a prisoner gets parole or not? So the prisoner comes up before the judges, and then they take into account their behavior, how long they've been in prison, what the crime was, all these different factors, and decide whether this particular prisoner deserves to get parole or not. And when they looked at all of the factors that fed into the decision, they found that the single most reliable determinant of whether a prisoner got parole or not was, in fact, when the judge had last eaten. Now, the judge wouldn't tell you that, of course. The judge would not say, I did not give that prisoner parole because I was hangry, and damn it, they didn't deserve it. They had good reasons. And they had, written down very clear and coherent reasons why they made these decisions. But this was the single most powerful factor on whether they actually gave parole or not. And the thing that gets me about this study is that judges didn't know that. We don't know a lot about the way we make our decisions. This is another of my favorite priming studies, and I have got a lot of other examples of priming, but I use this one because it has been replicated over and over again, and we have a slight replication issue in psychology, as in fact in many sciences, and part of that is down to the fact that scientists don't know anything about data science, but that's another rant for another talk. This study was the Honesty Box study in a UK university, I think it was the University of Sheffield, where they had an honesty box in the tea room. So where you had a cup of tea or coffee, you put a dollar in, a pound, to pay for the supplies, right? For 10 weeks, they put a picture above the box. And 1 week, it would be a picture of eyes, and the next week, it would be a picture of flowers. When it was a picture of eyes, people were 3 times more honest than when it was a picture of flowers. So all it takes to manipulate your behavior is a picture of eyes on a wall. And the interesting thing about the way they replicated this study is that they also replicated it using a mirror. So looking into your own eyes makes you more honest, which I think has some fascinating implications for selfie culture. But the thing is, as Jonathan Haidt describes it, we are just riders on an elephant, right? We are, the elephant is the subconscious mind, we are the rider, or the conscious mind is the rider. And if the elephant decides to go left, we are going left. And there is not much we can do about it. So what we do is we construct this quick reason, this rationalization without even knowing it. Well, of course I wanted to go left. I mean, the chocolate is over there. I know the coffee's to the right, but the chocolate is, of course I went to the left. We make it up as we go along, but we don't know that we do. Which leaves us phenomenally open to manipulation by organizations like Cambridge Analytica, who think that they can control the way we vote. We don't actually know whether they can or not, because it's not like we had a control group. Here's a group who's not being manipulated, here's a group who is, let's find out, because that would be totally ethical. But they think they can. People paid them a lot of money to. There is some evidence to suggest that they changed the course of the US election and the Brexit vote and all kinds of things. And this is the one we know about. Right, how much is going on out there that we don't know about? I like this Dan Ariely quote. We are pawns in a game whose forces we largely fail to comprehend. And he was talking about the way we make decisions, but I think it applies really well to data science because we don't know how it's being used against us, and we really don't understand it. So one of the things that I want to achieve with the Australian Data Science Education Institute is to make sure that at the very least, when we look at a graph, we understand what questions to ask. Where is the 0 on that scale? Where was the sample taken from? What was the sample size? Questions like that, so that we don't just bend at the knees when we see a graph. So that's why I created the organization. It's a registered charity. We train teachers to use data science in the way they teach science, history, geography, maths, all the things. Because it is relevant to all of the things now. It's the way the world works is underpinned with data. There are very few companies out there that don't have data scientists as fundamental to their operations. So with students, what we do is we do a thing called citizen data science. And it's based on the idea of citizen science, where ordinary people without a lot of training are starting to do science and provide scientists with extra data sets, and even analysis. And citizen science involves things like Climate Watch, where you put in information about bird sightings, plants, and a thing called the phenophase, which is what phase they are in the life cycle. For example, are birds nesting? Are they feeding their chicks? Are they mating? Are plants flowering? Are they losing their leaves? All that kind of stuff. And Climate Watch uses that to track changes in climate. Or they would if they actually had enough resources to analyze the data, which they don't, which is a fabulous opportunity for us. Penguin Watch is another one where you just categorize, are there penguins in this picture? And again, it's using the power of citizen science to analyze your data for you to try to speed up the scientific process. And I found with citizen science that, in fact, with the right training and using enough duplicates, so they get a lot of people to categorize one image. I think depending on the system, it can be 4 to 10 people categorize the same image. So you weed out the malicious people who are faffing about with your data, and you weed out the people who don't know what they're doing, and you actually get a remarkably reliable data set. Galaxy Zoo is another one where you categorize galaxies. But the thing about citizen data science is that it's an opportunity, A, to solve problems, and B, to engage kids with technology and with data. So the key thing is real data sets, meaningful projects, having an opportunity to actually find something, to actually make a difference, whether it's in your local community or in a much bigger context like the Climate Watch data set, to actually solve real problems. So it can be as simple as cleaning up your data. These are the default settings when you enter a bird sighting on Climate Watch. Can anyone see an issue with this?
Every bird is on a nest, but there is no nest.
Yes, it's very zen. Birds are on nests, but there are no nests. And this comes up in the data because these defaults, there's no checking in the website design. Let's talk usability for a moment. No, that's another talk. There is no checking to see whether the defaults have been moved, or no sanity checking to say, well, you can't have a bird on nest in the absence of a nest. So that's really easy. Those are CSV files. We can clean those trivially, just pull out the ones that say bird on nest and no nest present. Through to something as complex as this, which is a visualization, a heat map of neural activity from a neuroscience experiment. So we work with neuroscientists at Monash University, and they give us access to their data, and the kids who really want to push themselves and learn new skills will, first of all, work out how to deal with MATLAB data, and that's a world of pain in itself, and then produce nice little visualizations to show when the neurons fire under different stimuli. So in this graph, you can see the stimuli are up the left, and in this case, it's rat whiskers. So they're moving the whisker, and the stimulus is how far are they moving the whisker, and up the top, they're moving it further. So you can see there's more neural activity up the top. Okay, so you can't just set kids loose on a data set and walk away. We have to teach them about data cleaning, which is fraught in itself. We have to teach them about what kind of questions you can ask of a data set, and we have to teach them about visualizations, about putting a 0 on that scale and all that kind of stuff. So with data cleaning, sometimes we have issues. This is from a sleep study I did some years ago where you had to enter when you went to bed, what time you tried to go to sleep, so how long did you spend in bed that you weren't sleeping, for example, reading a book, what time did you wake up, and what time did you get out of bed for the day. The graph of my first month looked like this. And you can see if you look down this end, apart from the day that I forgot, I pretty much went to sleep as soon as I got into bed and got up as soon as I woke up. But something funky happened at the start here. Does anyone know what it was? I'll go back to the input screen. Right, hands up if you think in 24-hour time. There's always some, especially the techie audience, but I don't. So when well, there's a reason, right? Because it's unambiguous. So speaking in 24-hour time makes a lot of sense, but when you're dealing with ordinary users, it doesn't work, because ordinary users do not speak in 24-hour time. And by default, when I put in 11, it said 11 a.m. instead of 11 p.m., and I just didn't even think about it. So that first few times, you've got these crazy outliers in the data. Can I just throw those away? As a data science playing with that as a data scientist playing with that data set, can I throw it away? Why not? Well, you have to if you know. If you can go back to the user and go, Lynn, what was that? And you go, ah, sorry, 24-hour time, silly me. Chop those couple of days out, we're good. But my friend Shane is a firefighter. He does shift work. That could be a valid data set for him. So how do we deal with that? If we have 10,000 people filling out this tragic little web page, we can't go back and ask every one of them if they stuffed up the 24 hours. There's actually no good answer to this. Sometimes you can't clean the data. So we have to look at that.
Can you split the data in two?
Questions at the end, my friend. There's ways. There's ways you can deal with it, but there's no perfect answer, and this is a really important thing for the kids to learn, and this is why we use real data sets. For example, I am running out of time, so I'm going to, oh yeah, here we go. This is the election data set, right? This is each line, well, actually each pair of lines, because it's too large to fit on the screen, is one vote, apart from the headers at the top. So you have electorate, then polling booth, then a bunch of numbers we never worked out, and then the string, in quotes, is the actual votes. And it is 151 boxes, and each place is what was in that box, right? So the first thing you teach the kids, because they haven't voted before and the Senate voting rules are bizarre, the first thing you teach them is, what are the Senate voting rules? You can't have more than one in your vote, right? Except if you look at the fourth line from the bottom, there's 2 ones. Oh, crap. So people don't follow the rules? Who could have predicted that? You can only vote above the line or below the line, not both. Oh, uh-oh. Some people have done both. Man, these voters are dumb. Welcome to the world. Okay, how are we going to deal with this data set, right? So this is why we use real data, because the kids learn that it is not a sanitized, nice, neat, how many bananas did Mary and Fred have problem. It is a real problem with some really messy issues. It's great. And of course, the first question they want to ask is, when you say, find a question this data set can answer, they say, who is the best party? And I wish this data set answered this question, I really do. But you can't ask that. What does best mean? What you can ask is who got the most votes. That one we can do. And they're all a little bit disillusioned, I think, by that point. But this is important. What questions can this data answer? It can answer questions like, people who voted 1 for the Greens, who did they vote 2 for? It may have been predictable, but still an interesting question to ask. And those other questions, like, who followed the how to vote cards, and where did the people who voted for One Nation come from, and all that kind of stuff. So every student who did this project found their own question to answer. But the Python code was almost the same for all of them. So we were teaching the same skills, right? CSV file. First of all, pull out the data. Now, let's actually, okay, for those of you who need the electorate, we'll work out how to pull that out. That's the first field in your string. For those of you who just want to deal with the votes themselves, let's work out, first of all, let's look at the, do I have it here? Okay. Let's look at the ballot paper, because the ballot paper is kind of ugly. There we go. So we had to work out how that data matched this ballot paper, right? So we have a 151 place string, which has to map onto this. Just that was not straightforward. So I rang the AEC and like, tell me how this maps onto your file. They couldn't tell me. And they couldn't put me through to somebody who knew. There had to be somebody in that organization who knew, but I couldn't find them. So the only reason I was able to make this project work was because I was part-time, so I could spend my off time trying to work out what this data set actually meant. And eventually it turned out that each field in the string was left to right, top to bottom. So it was all the above the line votes first, and then across underneath, if there was no, you can see that the columns are different lengths. So the first three columns only have 2 boxes in them, and the third one has 6 or 8, something like that. The gaps don't exist in the string, right? So it turns out, and you see my mouse, we have 1 to 51 across here, 2, 3, etc., 52, 53, 54, etc. And then when you get down here, these boxes don't exist. So let's say this one is 112, this one will be 113. Not straightforward, right? And this is the thing. When I talk to people about the Data Science Education Institute and say, I would really like your data, they go, but there's a lot of data out there. Surely you don't have trouble finding data. I'm like, yes, finding it, not the problem. Making sense of it, big problem. Finding people in the organization who created it, who understand it. I don't understand how that could be a problem, but it is. So it is actually really difficult to set up a data science project unless you have a tame scientist who can explain their data. It's messy. So to scoot back here, so that's what the Data Science Education Institute is for. It's to find the data sets, make sense of them, write them up, put lesson plans around them, train teachers to use them in the way they teach, all of the things, because you know and I know that we don't have enough computer scientists out there in the classroom. We don't have enough people who can code out there in the classroom. So we can't all be standing up and teaching Python. We used Grok to get around that for a while, but it made the teachers really uncomfortable because they couldn't do it, and the kids would have problems, and they would come to the teachers, and the teachers would be like, well, I haven't done it yet. But I have some sympathy because they don't have time. So this is why we're trying to build these skills in, and we're starting with spreadsheet stuff because most people can manage a Google Sheets document, and building up to code. If I walk into a room full of science teachers and go, I'm going to teach you all the code, there'll be a whisking noise and the room will be empty. All gone. So we have to start where they are and build them up. Ultimately, of course, I want everybody to code, and the kids need those skills. But we've got to build them up one step at a time. And the thing about the feedback that we started to get when we started to do this stuff was things like this. It was so much more interesting than I thought it would be. They knew the relevance. They could see the relevance straight away. And some of them were starting to use it in other areas of their work. This is my favorite. We didn't see that this was going to be important until we started doing it. And I think that's central. And when we did the pretty pictures in Python, we didn't get that response. So we were teaching them the same skills. They were learning for loops, they were learning functions, they were learning variables, but they didn't see the relevance. As soon as you put it in the context of a real problem, they see the relevance. That is motivation number one. If you don't have relevance, you don't have a course. So we've put together a few resources. There's asking good questions of your data, which is that, okay, we can't really answer qualitative questions for the most part, but we can answer quantitative ones. What kinds of questions can we ask? And, you can do that in a general sense, but I'm also putting together lesson plans so that we can do that in a specific case. I can give people a data set from CSIRO or from data.gov.au or from the AEC or from the Bureau of Statistics and go, here is what it means, here is how you interpret it, here are some problems you can do with this. Here's the code version, here's the spreadsheet version, here are some small versions of the data set if you want to play with it in a spreadsheet and can't open it because it's too big. Just taking the work out of trying to build data science into your course and making it easy. So, resources are at the website. There is a link to the slides. Again, you can join the mailing list to be part of the community. You can help me find new data sets. You can help me build resources. As I said, we are a registered charity. There's a lot of people trying to make money in the STEM education space. It was really important to me that particularly low SES schools should be able to access this stuff for free, because funding should never be a determinant to the quality of your education. Shush. And that's me. Feel free to @me. Thank you very much.
Fantastic. Thank you so much. We have some time for questions. Yes, excellent. If you can introduce yourself and then ask your question.
Hi, my name's Steve Gale from Gordon Tafe in Geelong. I'm just interested to know, with the students and getting them to do some of those data analysis activities,
Yep.
what level of Python skills did they require?
Oh, look,
In other
I
words,
wasn't.
did they just need NumPy or did they need Pandas as well?
We weren't even going in NumPy level.
Right,
And
just
in
using
fact,
arrays.
I don't even use the CSV module, because
Right.
the more modules you use, the more magic it is. And they're
Yep.
like, I don't have to understand the workings, I just use this function to do it. So we tend to do very basic, pull out the string from the file, find the, break it up on commas, find the particular fields, really low-level Python skills.
So
of course,
using arrays and manipulating
yeah, using
arrays.
lists. So
Lists,
I have
right.
kids from zero programming experience through to been programming since they were in the womb. These guys, of course, you let them go. You're like, go for it. Use pandas, use Bokeh or one of the funky visualization modules, play. But the kids who are down here, you build them up level by level with just a few for loops, really basic list manipulation, string manipulation stuff. And you can do a lot with that.
Great, thank you.
Other questions? Yes.
Thank you. My name's Mark. I'm from Cisco. We do a lot of work with STEM initiatives in the country, in the rural areas.
Yep.
And one of the challenges that we see with some of the schools, we're not teachers, so we don't understand, is a 7-year-old going to be able to do this? Is a 15-year-old? So we don't understand what students are capable. Can you tell me, what does it take to get, and then what age do we get kids to start programming in Python?
Which kid? It's a really good question, but it is a little bit of a how long is a piece of string. At the World of Drones a couple of weeks ago, we heard from a guy by the name of Dan Martinez, who's doing Swift with his grade 6s, I think. And because they've done Scratch and they've hit the boundaries of it really fast, as you do with Scratch. I would like to say I have nothing against Scratch, but I'd be lying. I think you could actually start with Python as soon as the kids could read, but it depends on the kids, it depends on the teacher's confidence, it depends on the way you introduce it and the context in which you introduce it. There's no hard and fast rules about this. It's like saying how old is a kid when they can read. The school system likes to think it has an answer to that, but it really doesn't. It depends on the kid and depends on the teacher and so many factors. But there really isn't a point where you go, well, this is, except when they can't read. There really isn't a point where you go, programming in Python is beyond this kid. My 11-year-old started doing it really, I think they were 6 when they did their first Python program. And I wasn't teaching them because the last thing I wanted to do when I came home was teach more Python. They did it themselves. So,
So do you recommend starting with Python as opposed to, make block and Scratch and all those other things?
I recommend the block-based stuff for really little kids. Because they can plug and play and they can build up a little bit of confidence and experience. I actually don't think that block-based programming is teaching programming. That's a very contentious viewpoint. Started something of a flame war on Twitter about that just the other day. But there is no evidence that the skills in block-based languages translate to text-based languages. That doesn't mean it doesn't happen, but there haven't been studies that have really proven that yet. And I think if you're going to teach programming, you should be teaching text-based languages. There's so many issues with block-based languages around the error messages, around the feedback, but there are issues with text-based languages as well. Error messages, They exist, at least, but they're terrible. So it's one of those things where there isn't really a good solution yet, which is why I designed my hideous language. But
we've got time for one more question.
Linda, thank you for the talk. Could you describe the environment in which you teach these skills? Like, do you have a main teacher and a co-teacher? Do you have peer teaching between the students? How many students per class? What's your experience with that?
good question. I have pretty much taught it in every possible context. The standard context at John Monash is 2 classes and 2 teachers. There were very rarely 2 skilled teachers in the same room. For the Year 11 course, we had 2 skilled teachers, and I co-developed that with Victor Rajewski, and that was amazing because we could split into advanced kids and beginners, and we could, really hit all of the levels much more easily. But with the Year 10 classes, there were generally 50 kids in the room, 1 teacher who knew how to code, 1 teacher who was going around, in some cases putting out spot fires, in some cases sitting up the back not doing anything. We had them teaching each other, although that's risky because you get the kids who've been doing this forever, hands fly over the keyboard and suddenly it works, and the kid whose keyboard it is has no idea what happened. So we have a no inappropriate touching rule, which is nobody touches anybody else's keyboard. That helps a lot, but it's still intimidating for the beginners to have the advanced kids explain things to them. We had also older kids coming in and teaching the younger kids. They would be appalled to hear me call them kids. But my Year 11s would come in and teach the Year 10s, and my graduates often came back and helped in the classes. And without that support, it would have been so much harder. So, sometimes my graduates who haven't programmed in Python for a while would be like, I don't know if I can help. I'm like, if you can just deal with the syntax errors, just put out the spot fires, then I can work with the ones where we have to do some serious debugging, and it was phenomenally useful. So their support was just priceless. Ideally, you'd want at least 2 skilled teachers in the room, but most schools don't have that option.
All right, thank you very, very much. One more round of applause for Linda. She's doing amazing, amazing work. We have morning tea.